to show you as well. Whoops, far. Let me move forward. I hit instead of forward. So this is the old versus the new nomenclature table. So normally we would call, so a copper +1 ion would be called copper, and then parentheses, Roman numeral 1 ion. Okay, so that would be copper 1, is what we would say out loud. Now the old name would be cuprous, and then copper 2 would be called cupric. So that OUS ending versus the IC ending, the OUS just goes with the lower charge, and the IC ending goes with the higher charge. The problem is that you have to remember what the charges actually are, right? So that's the hard part of the old nomenclature. The new nomenclature is easier to remember. The Roman numeral just matches the charge. You can learn the old nomenclature if you like, but I will test you on the new nomenclature only. If I give you a question where you have to write the name, the old nomenclature would be fine for the correct answer. But when I give you a name and I want the formula, I will give it in the new name. Okay, so I want you to know the modern name. The old name would be fine as an answer as long as it's correct. Make sure you know what you're doing if you're going to do it that way. We're going to practice these. I think it would make more sense once we practice them. Okay, so writing a name from a formula. The cation is always listed first. That's the positively charged ion. The anion is listed second. That's always true when you're writing the name. But it's convenient because that's the way we write the formula as well. Cations are the same. The name of the cation is the same as the name of the element. So sodium cation is just sodium, same as the sodium atom. The anion, you change the ending to "ide." So chlorine atom becomes chloride ion. So we're going to do an example in a minute. Number 2. You need to know element names that were identified earlier. So earlier in the semester when I told you I wanted you to know certain elements from the table, go back to that. Those are the elements I want you to know the name of. So it's not every element on the table. I don't remember all the elements on the table either. Number 3, you need to memorize the formula for the polyatomic ions. You need to be able to associate the formula and the charge with the name. So you might want to make flashcards as soon as possible and then put the ions that are in table 3.1. That's the table I showed you a few minutes ago. So for example, you might write sulfate on one side and you might write SO4 - 2 on the other side. Okay, you need to be able to go from one to the other or backwards, either one. Okay, so the idea behind writing a formula from a name is that you want to combine the cation and the anion in a way that gives a neutral overall charge, 0 charge overall. So you put ions together to make a neutral compound. And so it's kind of like a game, right? You have to put things together to get 0 overall. We're going to practice this next. So first we're going to practice writing a formula from a name. And the idea here is you need to put ions together to make a neutral compound. So on the left we have cations, on the right we have anions. Remember, we're always going to have a cation with an anion. The positive charge goes with the negative charge. So if you're going to combine them, they have to add up to 0. And so if you take a sodium +1 and a chloride -1, and you put them together with 1 sodium and 1 chloride, then they become 0. And that's good. That's what we want. So sodium chloride has 1 sodium and 1 chloride. If we take calcium and we combine that with oxide, 1 to 1, those would add up to 0. So calcium and oxide combine in a 1 to 1 fashion so that we get an overall charge of 0. Aluminum and nitride have the same, aluminum's +3 and nitride's -3. So these will combine 1 to 1, aluminum, nitride, to give a sum of 0. But these things don't always add to 0. What if you're combining sodium with nitride? Or what if you're combining aluminum with oxide? So in those cases, you need to use different numbers. So sodium and nitride are not going to combine 1 to 1. You need 3 sodiums to balance out the -3 from the nitride, right? That gives you +3 from sodium and -3 from nitride. So you're going to get Na3N. So you will do a little subscript 3 next to the sodium. And that's how those combine to form a neutral compound. Now let's instead combine aluminum ion and hydroxide. Hydroxide is -1, aluminum is +3, so we need 3 hydroxides. Now because hydroxide is polyatomic, we need to write it with a parentheses. Like that. Otherwise, you can't just put the 3 there, otherwise it only refers to the hydrogen. So you need the parentheses so that the 3 covers both the O and the H, hydroxide. We need those because they're 3 separate hydroxides, right? We have one more set of practice problems that we're going to do. For each of the following compounds, provide the name. You need to memorize the names of the polyatomic ions. It would be helpful if you practice this after you've done that memorization, because otherwise it's not going to be as helpful to you to practice when you don't know the names. So probably flashcards would be useful to use before you do these practice problems. This first one, NH4 with a +1 charge is ammonium ion, NO3 with a -1 charge is nitrate. So when you put them together, the compound is ammonium nitrate. Spelling is pretty important. Sometimes I give partial credit if you're close, but often the misspelling produces a different word. So for example, nitrate is a lot like nitrite, but those are two different ions, and so I would give you 0 credit if you wrote nitrite. So best to just spell everything correctly, and then you don't lose any points, because you might lose all of them even if there's only one letter different. It just kind of depends. The second one here, magnesium, is an alkaline earth metal. It's in group 2, so it has a +2 charge. And then the ion that's with it is hydroxide, so that's magnesium hydroxide. This third one here, K, is potassium. And H, when it's an anion, is hydride. Hydride is H with a -1 charge. That's a very commonly missed one. A lot of people forget about hydride. Hydrogen can lose an electron to be hydrogen cation, H+, or it can gain an electron to have a full valence shell and be H-. Because it's combined here with an alkali metal, you know that potassium is definitely a cation, so you know hydrogen is present as hydride, H-. Another reason you know that it's an anion, hydrogen is present as the hydride anion, is because it's listed second in the formula. Nickel is a transition metal, and so nickel can be +1 or +2, and so fluoride is the anion listed there for NiF, and fluoride is definitely -1 charge, which means that this is definitely nickel +1, and so when you name it, you have to give it the transition, you have to give it the Roman numeral 1, nickel 1 fluoride. And so this 1 here that I'm highlighting is because it's the +1 charge. The older nomenclature for nickel would be either nickelus or nickelic fluoride, and this one would have the OUS ending because it's the smaller charge. But I'm not going to ask you about the older nomenclature. We're gonna do Roman numeral nomenclature. If you did it the other way, as long as it was right, I would give you credit for it, though. And sometimes you see those on, jars of chemicals in the stockroom too. So it's not crazy for you to know them if you're interested. Number 2, for each of the following compounds, provide the formula. Okay, so this is actually the most challenging part of naming these is writing the formulas, I would say, for the ionic compounds. Writing the formula is probably harder than writing the name from the formula. So 2, I think, is probably harder than 1. So I'm going to spend a little bit more time here. Calcium bicarbonate, we'll start with calcium. Calcium is a cation. It's in group 2, so it's an alkaline earth metal, and it's +2 charge. So this is the formula for calcium bicarbonate. And this is because calcium has a +2 charge, and I know that because if I go to my periodic table, calcium is in group 2, it's here, and group 2 is a +2 charge. Bicarbonate is something that you would have memorized. This would be something that you would use your flashcards for. You need to memorize the polyatomic ions. Bicarbonate or hydrogen carbonate, you need to know both names. Bicarbonate is a more commonly used term. So you would have bicarbonate ion on one side and you would have HCO3 minus 1 on the other side. Now, because you need 2 bicarbonates to balance the charge for calcium, right, 2 minuses to match the 1 plus 2 charge, then you use the parentheses and the subscript 2 for bicarbonate. Lithium phosphate is Li3PO4, and this is because lithium has a +1 charge because it's in group 1. If we go to the periodic table, lithium is here, and that's in group 1, which has all of the group 1 alkali metals have a +1 charge. And you know phosphate is -3 because you would have memorized that as a polyatomic ion. So if phosphate is -3, you need 3 lithium ions to balance the charge of 1 phosphate to give a 0 net charge. The third one is aluminum nitride. Aluminum is in group 3, so it has a +3 charge. It is here. Group 3 is always +3. Nitride is here. It's in group 5. So if you start with the noble gases and you go backwards 1, 2, 3, then you end up with a -3 charge for nitride and anything in that group as long as it forms an anion. So aluminum's +3 and nitride's -3, so they balance out 1 to 1. So you just need 1 aluminum and 1 nitride, and you get ALN as the formula. The fourth one here is iron 2 oxide. That 2 means that iron has a +2 charge. So we're going to write Fe +2, and then oxide is -2. And the reason I know that is because from the periodic table, if we start with the noble gases, oxygen's here, we go backwards 2, 1, 2. So from the noble gases, the halogens form -1, and then next to these, they're called the chalcogens, they form -2. So oxide is O -2, and you know that from the periodic table. So you know these combine 1 to 1 because iron is +2 and oxide is -2. So you don't need any subscripts. Now, last but not least, figures to the right represent solid ionic compounds in which the blue spheres are cations, that's positive ions, and the red spheres are anions, those are the negative ions. So I'm going to go ahead and label them so that I can use them more, so that I can see them more clearly. The blue spheres are positive, the red spheres are negative. We don't know the charges, but we can count them and see the ratios. So if you look at the first box here, you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cations for every 1, 2, 3, 4, 5 anions. So that means you have twice as many cations as anions in box 1. So twice as many cations. So all we need to do is find a formula down here where there are twice as many cations as there are anions. And so you're going to look for one with a subscript 2 for the cation and a no subscript or understood subscript of 1 for the anion. So it appears that potassium oxide fits that description. So I'm going to put a 1 here, or lithium sulfide, which is down here. I'm going to put a 1 there. Now the second box is going to have an equal number of cations and anions because there's 10 of each. So for these, it's totally irrespective of the charge. You just need to find different salts where there is a 1-to-1 ratio. So it appears that that occurs here for sodium bromide. So I'm going to put a 2 there. Magnesium oxide, I'm going to put a 2. And aluminum nitride, I'm going to put a 2. And so even though sodium bromide, sodium is +1 and bromide is -1, magnesium is +2, oxide is -2, aluminum is +3, nitride is -3. The actual charges aren't required to answer the question. All you need to know is the ratio. So since it's 1-to-1 that we're looking for, all 3 of these could be the answer to this question.